Okay, welcome to physics. This is section 2.1, picturing the electric field. And it's remarkably simple. This will be a short video. When we think of the electric field, what we do is picture something that has a charge on it. It could be a sphere, it could be anything, but we've got a positive charge. And what we do is we say, what if I put a positive charge near it? Always positive. We test with a positive. If the lines are going away, that means they're repelling. And so this would be the field, the electric field diagram for a positively charged object. If this had been a negatively charged object, we would think of that positive charge and what it would do, and the lines would all come toward it. And that is your basis for what we're doing, something like that. Right? Now, what is interesting is what happens when you put charges next to each other. Let's say I had a positive charge and a negative charge. If I put a charge right here, this would go straight across. It would be repelled by positive, attracted to negative. If I put a positive charge here, if this wasn't here, it would just take off like that. But at some point, in fact, right at the beginning, there's going to be a tug from this. And so this actually ends up looking something like that. If we put a charge here, if this wasn't here, it would go perfectly straight up. But just like before, there will be an attraction, and this will work its way around. You say, well, what about this one? Well, if there wasn't anything, it would go like this, but it is going to be tugged on by that one, and it's going to work its way around. If it was here, this would go this way, and theoretically, it would go all the way around the universe and come back here. And then the bottom side is going to be the same. A lot of students don't do this, but you want to put it on. And that would be kind of like a picture of a butterfly, or sometimes to me it looks like Homer Simpson. I don't know why. That is what would happen. Okay? So let's say, I'll do this over here. Let's say I had two positive charges. If I did two positive charges and I put a positive charge, it would start going this way and it would get right to the center and it would stop. It would be perfectly balanced. But actually, it hardly ever can go exactly perfect. And so what would happen is it would go like this. We'd actually have an asymptote here. And we'd have the same thing on the opposite side. And then an object right here normally would go like this, but it's going to be being repelled. And this will end up going out like this. This one, which would have gone up, ends up going out like this. This isn't quite as much, and you end up with a field that looks like this. And by the way, this would be symmetrical. Something like that. Those are electric field lines. Now, what's interesting is if you were to take a different type of object. Let's say I took something that was a plate, and this plate had positive charges all along it. And I put a negative charge here. This is all negatively charged. And this is actually what a battery does, or a capacitor, which we haven't talked about yet. But if I put a little positive charge here, what's it going to do? It's going to get pushed from here and go straight down. And we actually would get an electric field that would look like this. And if you said, well, what would happen on the other side? Any charge here would also be coming up. And any positive charge, remember we're always using positive, would go this direction. But most of what we'd be interested in is in the inside. What's interesting is around the outside. If you had a charge out here, it's going to go this way, but it's actually going to work its way around like this. And you end up having something similar around the outside. You actually get kind of a shape that looks like that. I have a handout. I'm actually going to upload it for you. It's 2 pages, and it just has some diagrams to draw. There's an interesting one on there that looks something like this. If this is positive, positive, or positive, negative, actually, then in that case, anything here would just go straight down. Any positive charge on the inside would go straight out this direction. And any negative positive charge on the outside would take off this way. By the way, we always put arrows in Oops, I should have done that all the way along. All of these would go out like this. So that is picturing the electric field. It's not hard. The video pointed out, I think, that Faraday did not know any math. And he had to picture the electric and the magnetic field in his brain. And this is what he came up with. And yet it is such a powerful idea that even though these lines don't technically exist, this is the way physicists think about electricity as charges that are being pulled in somewhat of, almost like there's a line or an electric field line that's pulling them there. It doesn't actually exist, but it's a useful tool to figuring out what is going to be happening. So, all right, short video, like I said. There's a homework that'll go with it, and that'll all be up by tomorrow. So, all right, with that, we'll go ahead and stop.